Tonight we're going to look at word problems, specifically word problems that can be solved by writing linear equations. And by linear equations, I mean writing the equation in the form y equals mx plus b. So we're going to take a look at this word problem. Sorry, it's up here. The 8th graders are selling t-shirts and caps to raise money for their year-end party. They earn a profit of $5 per shirt and $10 per cap. So we want to go ahead and define some variables over here. Whoops. So the number of t-shirts sold, we'll use the variable t. The number of caps sold, we can use the variable c. And then the profit, we can use the variable p. So the profit for the fundraiser depends on the number of caps and the number of t-shirts sold. So I'm going to underline that word depends, and we'll come back to it later. So what equation shows how the profit P is related to the number of shirts sold, S, and the number of caps sold? So if we add up the number of shirts sold plus the number of caps sold, that'll give us our profit. But we don't want to write the word problem in words, we want to use variables. So we know from up here that there's $5 profit per shirt and $10 profit per cap. So the equation we can use is $5 for every shirt plus $10 profit on every cap is going to give us P, which is our total profit. So this is the equation we're going to use to answer part B. So part B, we need to find the profit if the student sells 30 shirts and 50 caps. So we defined our variables up here, so we know T is the number of shirts sold and C is their number of caps sold. So if we use our equation 5S plus 10C equals P, and then just plug in what we know that we sold 30 shirts and we sold 50 caps. That will give us our profit. And we work that whole thing out by selling 30 shirts and 50 caps. We get a profit, I'll write it up here, we get a profit of $650. So we can use this equation to help us find combinations of shirts and caps to make a profit, or if there's a certain profit we're looking for, we can use this equation to determine how many shirts or how many caps we have to sell. So go ahead and try number 2 and 3, 15 shirts and 10 caps, 12 shirts and 20 caps, so we can figure out our profit on those. Pause the video and then you can check your answer. So again, we're using the equation 5S plus 10C equals our profit. We sold 15 shirts, so it's 5 times 15, and we sold 10 caps. That's going to give us our profit. So then we get 75 plus 100. So our profit is $175 if we sell 15 shirts and 10 caps. So number 3, same thing, $5 per shirt plus $10 per cap gives us our profit. We're selling 12 shirts and 20 caps. And to figure out our profit, that's going to give us 60 plus 200. So our profit from 12 shirts and 20 caps is $260. Pretty simple. Okay, so there's two common forms of a linear equation, and the form that we've been using the past week is y equals mx plus b, but this is another form of a linear equation. We have two variables, s and c, so we can figure out what our profit is. So there's two forms of a linear equation. When the values of one variable, and here's the important word, depend on those of another, it's most natural to express this relationship in slope-intercept form. It's y equals mx plus b. And we call this, and we've done this before, we use the slope, and we use the intercept to graph the equation. So when it's more natural to combine the values, which is what we're doing up here, we're combining the number of shirts and the number of caps to get the profit. When we combine the values, we get this form, which is ax plus by equals c, and we call that standard form. Of the linear equation. And the equations in number 1 were in standard form. So why would we use one over the other? It depends on how our word problem is set up. So for slope-intercept form, if one value depends on the other, that's where we use slope-intercept. If we need to combine the variables, or combine the values, that's when we would use standard form, and that's how this is written in standard form. So it's easy to graph an equation in slope-intercept form, which is y equals mx plus b, on a calculator, but can we use the calculator to graph an equation if it's an ax plus by equals c form? And no, because we need our equation in y equals. So can we change the equation from ax plus by equals c to form slope-intercept form so that we can put it in the calculator? And the answer to that is yes. So how do we do that? We just have to solve for y. So in our equation right here, 600 equals 5s plus 10c, we can also write that using the variables x and y. So 5 times the number of shirts plus 10 times the number of caps will give us our profit. And let's say, for example, we want our profit to be $600. We can figure out combinations of x and y that will give us 600. So if we want to solve for y, we first subtract 5x from each side, and we get 10y equals negative 5x plus 600. We need to get rid of that coefficient of y, so we divide everything by 10, and what we end up getting is y equals negative 1/2 x plus 60. And this is where y equals the number of caps, and x equals the number of shirts. And in this particular one, the profit we were looking for was 600. So we can find combinations of x and y that will give us a profit of 600. And this is what we're going to work on in class tomorrow. So now it's your turn to answer multiple choice question number 1 in free response. A plumber charges $50 for a house call plus $25 per hour of work. So $50 a house call and then $25 per hour. Write an equation in slope-intercept form. That's y equals mx plus b to model a scenario. So when we look at this, what's the flat fee? What am I charging per hour? Number 2, here's your equation in number 1. How much would it cost to have a plumber working at your house for 2 hours? And be sure to include units. Make sure you put your answers in the Google form and work both these questions out in your notes.